Hi everyone, good evening. Good evening everyone, welcome back to another session. Let's start. First of all, quickly let me know in the chat box if I'm audible and visible. Be quick. I think I'm live now. Yes, we are live. Great. Hello. Good evening, good evening. All right. Okay. Chalo. Shall we begin? कल क्लास क्यों नहीं लिए? There was no plan for any physics class for yesterday. I think you had chemistry or biology for yesterday. That's why, dear. बहुत wait किया. Okay. Hello. Waiting for my session. Okay, I'm here now. Let's start. All right. Chalo. Let's begin, दोस्तों. Let's begin without any delay. Let's start with first question. By the way, in this lecture, I've included questions from different years. Some of the questions are from mains, some of the questions are from previous year, but level of question is going to be above moderate, right? So let's start. This is the first question, dosto. The question says, from a disk of radius capital R and mass capital M, a circular hole of diameter capital R whose rim passes through the center is cut. What is the moment of inertia of the remaining part of the disk about a perpendicular axis passing through the center? Let's start. Time is 90 seconds. Let's begin. And simultaneously, I'll be drawing diagram for you. They are saying that we have got a disk like this. And we have got another disk. We have actually cut out another disk somewhat like this. All right. And whose rim passes through the center is cut, right? So this has been cut. This has been cut like this. And then you have to find out the moment of inertia of the remaining part of the disk about a perpendicular axis passing through the center. About a perpendicular axis passing through the center. First of all, let's start by saying कि भाई complete disk has radius r and mass m, right? Please know that any mass can be actually written as sigma multiplied by area, and area of a disk is 2 pi r square. Sorry, area of disk is pi r square. Or I can say that mass is directly proportional to r square. Mass is directly proportional to r square. So if let's suppose somebody is telling you that mass of this disk is m, then mass of this cavity will become m by 4. How's that? Let me tell you, because this radius is r by 2. If the complete radius is r, then this radius will be r by 2. And note that this radius is r. This radius is r. All right, clear? Done, my dear friends. So this mass is going to be m by 4. Now pay attention. They are asking about moment of inertia about this axis. Moment of inertia about this axis. So first of all, we all know that let me call it as axis I, right? So moment of inertia of the complete rod is going to be mr square by 2. Moment of inertia of complete disk is going to be mr square by 2. Now let's also subtract the moment of inertia of this rod. By the way, moment of inertia of this rod about this axis will be m by 4 into r square by 2. Just a second, let me write it again for you. This is I dash and this is going to be m r square by 2. Got it? So instead of small n, I am going to write mass of this disk and it is capital M by 4, and instead of radius I am going to write r square by 4. So this will be m r square by 16. Is it fine, my dear friends? Quickly write down in the chat box. Is it absolutely clear? I am talking about moment of inertia of this cut out disk about this axis. And this perpendicular distance is r square. Sorry, this perpendicular distance is r by 2. So moment of inertia of this disk about this axis is going to be this mr square by 16 plus mass of disk, that is m by 4, multiplied by the square of this distance, that is r square by 4. So again this will become mr square by 16. So this will become mr square by 8. Quickly let me know in the chat box if everything's clear, right? Yes, obviously we are going to subtract. Please hear me out again. I have said that moment of inertia of this cutout about this axis is mr square by 16. So this is going to be m, mass is m by 4, and square of this distance, that is r by 2. So that means becomes r square by 4. This is again become this becomes mr square by 8. Hopefully everything is sorted and clear. Quickly let me know in the chat box, दोस्तों, if you have any doubt. Be quick. Be quick, दोस्तों. Be quick. Clear? And I have also multiplied 2 over there, na? Sorry, I have missed 1 2. So 1 2 will be also over here. 1 2 will be also here, दोस्तों. This 2, बच्चे. This 2. Okay. So 1 2 will be also over here. 1 2 will be also over here. So this will become mr square by 32. So this will be mr square by 32. So this will be mr square by 32. This will be mr square by 32. So finally we'll get this is 16. So multiply 2 multiplied by 2. So this will become 3 mr square. 3 mr square by 32. Now subtract it. So minus mr square by 32. Please check everything's clear. Hopefully everything is clear. We can multiply 16 over here. We can multiply 16. Finally answer should be 15 mr square by 32. So 15 mr square by 32, option 1 is correct. Option 1 is absolutely correct. Some of you have said option C also. I don't think so. Third one is correct, but I'll take your doubt. Let me know in the chat box if you have any doubt. Clear? Once again, please, sir. Yes, question is definitely of nice difficulty level, we can say. See, the question is saying, let me explain it to you. The question is saying that we have got a disk, right? We have got a disk of mass m. Disk of mass m, radius is capital R. From this disk, I am explaining it, Kaushi, don't worry. From this disk, we have taken out a cavity. Cavity has radius r by 2. So what I am saying is, please remember that mass can be written as sigma multiplied by area. That means mass is directly proportional to r square. So if you are decreasing radius, please see, if you are decreasing radius from r to r by 2, your mass will go from m to m by 4. So that means mass of this cutout disk is m by 4. Right? Now let's find out the moment of inertia. What is this, by my dear friend? What is this? This is moment of inertia of cutout disk about center. Of course, I can write about axis passing through center, but I am just saying that this is moment of inertia of this disk about this axis passing through this. Okay? So how we are going to find the final answer? The moment of inertia of this disk is mr square by 2 minus moment of inertia of this disk. That comes out to be, we have done some mistake, yeah? You have done some mistake. This is going to be 3 mr square by 2. Oh ho, this is going to be 3 mr square by 2. So this is going to become silly mistake. First question and silly mistake. Very bad. This is 3 by 32 mr square. Na? So this is going to become 13 mr square by 32. So correct answer should be B here. I don't know what you have, many of you have selected B, I guess. 13 mr square by 32 is the correct answer, because this is 3 mr square by 32. So B is the correct answer, dosto. My bad. B is the correct answer. Chalo, quickly let me know in the chat box. Absolutely, B is the correct answer. My bad. I missed this 3. I have written this 3 over here, but I missed it over this on this part. So this is going to be your final answer. B second is the correct answer. My bad. My bad. My bad. हाँ, answer is B. Answer is B. My bad. ठीक है? Clear? I missed this 3 here. I missed this 3. Now everything's clear. Can we move on to the next question? Yes, this is from 2016. It was a nice paper. ठीक है? A square loop ABCT carrying current I is placed near and coplanar with long straight conductor XY carrying current I. The net force on the loop is. ठीक है? चलो, let's start. Net force on the loop. 90 seconds. Let's begin. Now, if you have any doubt in the last question, you can ask, else we are moving on. B is the correct answer. My bad. By the way, in this question, you can use the concept of parallel current carrying conductor, right? In this, current is moving in this direction. In this part, current is moving in this direction. Current is I and current is I. So, like direction, attract. So, attractive force will be drawn in this direction. This is the force of attraction. This is force acting on AB wire. This is force acting on CD wire. Force acting on CD wire. This length is L. So this length is also going to be L, because they have said that it is a square, है ना? It is a square loop. Clear? So use the formula of F equals to mu naught upon 4 pi 2 I1 I2 mu naught upon 4 pi 2 I1 I2 multiplied by L divided by D. You can use this formula and remember this also. Okay? This is a very important formula. Force acting between two parallel current carrying wires. Okay? So F, let's now quickly find out FAB. Let's quickly find out FAB. So FAB is going to be, they are giving answers in mu naught and 4 pi, so I don't have to worry about putting the values. 2 current is capital I and in this current is small I. So 2 capital I into small I, and length of this is L, and the separation width was L by 2. So width was L by 2. Acha, you can also do one thing. You can also use BIL formula. You can also do BIL formula. Okay? But I think this is absolutely fine. If you are going to closely see, I can cancel out, by the way, these two things. Right now I am getting my answer as mu naught upon 4 pi 4 capital I small I, and definitely I can cancel this L. Okay? So this is my final answer. I can cancel out this 4 also, but hold on. And then again, let's find out FCD. So this will be mu naught upon 4 pi, again 2 capital I small I. Doston, length is capital L, and now this length will become 3L by 2. 3L by 2. So this L will get cancelled out and you will get mu naught upon 4 pi, and this will, you will get 4I small I divided by 3. So obviously this will be greater in magnitude, as you guys can see. So net force is going to be mu naught upon 4 pi I times I, and this will be 4 minus 4 by 3. That means 1 by 3. So mu naught I upon 4 pi, and you have got 3 over here. So you can change it in different terms now if you wish. Just check. Be quick. 4 minus 4 by 3. 3L by 2. Kindly check दोस्तों. अच्छा, they are not, this is, they are giving answers in L. They are giving answers in L. Okay. They are giving answers in L here. All right. So let's do one thing. If they are giving answers in L, na, then let's do one thing. Let's write down BIL. Then let's write down BIL. Force acting on AB will be magnetic field B I into L. Right? Magnetic field, see what formula I'm using. Magnetic field due to straight current carrying wire, due to straight current carrying wire, current I of the loop, and L is the edge length, of this, right? And magnetic field of the wire, I am going to write it down as mu naught I upon 2 pi into D, 2 pi into D, right? So I am going to write down mu naught upon 2 pi. Instead of D, first I am going to write L by 2, and this current I am going to write it down as I, and length I am going to write it as L. I think we are getting the same answer, na? I think we are getting the same answer. There is no difference. Tell me, dosto. I don't think there is any difference. We were getting mu naught I divided by pi, and in the second one we were getting mu naught I divided by 3 pi. I think in the second one we might have done some mistake here. It was absolutely correct. Our answer was absolutely correct. I thought we have done some mistake, but in this also we were getting mu naught capital I small I divided by pi, and over here also we are getting the same answer. Mu naught capital I small I divided by pi. We are getting the same answer. I think we were also getting same answer in CD also. In CD we were getting, my dear friends, we were getting 2 mu naught I divided by 3 pi. Mu naught I divided by 3 pi. This is what we were getting. Mu naught I divided by 3 pi. Mu naught I divided by 3 pi. And if you are going to subtract these two, your net force will come out to be mu naught I divided by pi minus mu naught I divided by 3 pi. So that means 3 and 3, and this will come out to be 2 mu naught I divided by 3 pi. So 2 by 3 is in this and in this. So 2 by 3 mu naught I divided by 3 pi. Dosto, answer 1 is correct. Answer 1 is correct, my dear friends. Answer 1 is correct. Let me explain it again to you. We might have done very good. See, let me again explain it to you. You can use any method. If I am going to write down FCD again for you, you can write it down as mu naught upon 4 pi 2 I1 I2, so I into I, right, multiplied by the length of the wire, capital L, and this is 3L, this is 3L by 2, this is 3L by 2, right. So if you want, we can cancel out this, and you can cancel out this, so you are getting mu naught I divided by 3 pi. You are getting the correct answer here, correct answer. See, same answer. Okay? So answer 1 is absolutely correct. Chalo. Next is the magnetic susceptibility is negative for, come on, 30 seconds. 30 seconds, dosto. Magnetic susceptibility is negative for which material? Very easy. For paramagnetic, magnetic susceptibility is positive and small, very small. For ferromagnetic, it is positive and large, right? Paramagnetic and ferromagnetic, so it's going to be obviously diamagnetic material. Paramagnetic susceptibility is negative for this. So option A is correct. Good, very good. Moving on to the next one. Chalo, this one is a nice problem. Nice question. Please see. In this question, they are saying capacitor 2 microfarad is charged as shown in the figure, in the diagram. When the switch S is turned to position 2, that means initially it was turned over here, then we have switched the position to 2. Then you have to find out the percentage of stored percentage of its stored energy dissipated is. Chalo, let's start. 90 seconds, let's begin. Quick. First, it was connected to this orientation, and then we have connected it to this orientation. Come on, be quick. Find this one out. When you are going to connect this capacitor with this battery, it will get a potential of V, right? And charge of CV, that means 2 into V. This is the initial condition. And then after getting charged, now we are connecting it with second one. So when you are going to connect it with second one, there will be some energy loss, right? Is not showing options. Pi lens is not showing options. Let me check. Pi lens is not showing options. Okay, I'll check. No problem. I'll ask someone to see. Just a second. Chalo. First of all, let me explain this question. So, my dear friends, what you can actually do is, first of all, find out the initial energy, because they are saying a capacitor of 2 microfarad is charged as shown in the diagram. When switch is turned to the position 2, the percentage of its stored energy dissipated. So, doston, the initial energy is half C V square. So, C is 2 and V square is simply V. That means initial energy is V square. Initial energy is V square. Now, my dear friends, we all know that the formula of energy loss. So, simply apply the formula for energy loss, that is half C1 C2 divided by C1 plus C2 times V1 minus V2 whole square. V1 minus V2 whole square. So, when you are going to apply it, you are going to get, and by the way, this is dissipated, this is nothing but this is dissipated, loss. So, it's going to be half C1 C2, that means 2 into 8 divided by 2 plus 8, that is 10, and V minus 0 and whole square. So, 2 can be cancelled out. This will become 4, this will become 5. That means we are getting 4V. We are getting 4V by 5. We are getting 4V by 5. This is dissipated. Got it? This is dissipated. Kindly understand. So, if somebody is asking you the percentage of this stored energy dissipated, so what you need to do is you need to multiply what is the energy lost. Energy lost is 4V by 5. 4V by 5. Right? 4V by 5 can be actually written as 0.8V. Is that correct? It can be written as 0.8V. So, percentage loss will be written as 0.8V divided by initial energy. So, initial energy was, and by the way, this is going to be V square. So, this is going to be V square. So, this will be 0.8 V square divided by V square multiplied by 100. So, V square can be cancelled out and we are getting our answer as 80%. Nice problem. 80 is the correct answer. Fourth. Most of you have thought it is 75%. It is wrong, my dear friends. Only 3 students have got it correct. 80% is the right answer. Clear? Is there any problem in the pi lens? Shall I ask someone? Refresh. Is there any problem in the pi lens? Clear? D. All right. Chalo. Please understand, we are talking about percentage, not percentage change. है ना? Don't find out percentage change. We need to find out percentage. Sir, 75 होगा, नहीं होगा. This is absolutely correct. D कैसे हो गया? Okay, let me explain it again. Then I am going to move to the another answer, another question. Please see. देखो, it is very simple. Initial energy is V square. Initial energy is V square, no doubt about it. Correct? Just a second. Initial energy is V square. Loss is 4V square by 5. So, this is the dissipated, na? This is the dissipated, right? This energy is being dissipated. Kindly see. This energy is being dissipated. So now if somebody is asking you ki what percentage of energy is getting dissipated, so what you are going to write down is that energy dissipated divided by total divided by initial energy multiplied by 100. So that's what I have done. 4v square divided by 5 divided by v square, because initial energy is v square multiplied by 100. V square gets cancels out. This is 20. Answer is 80%. All right. So I have explained it again. Now still if you have doubt, just read it again. You will get it. Okay. You might be getting confused in percentage change. They are not talking about percentage. They are simply talking about percentage. Right. Chalo. Moving on to the next question. 90 seconds. Let's start. This question is saying time is started. In a diffraction pattern, first minima is at 30 degree, then find out the secondary maxima. At what angle secondary maxima is obtained? Done. Now your doubt is clear now. If your doubt is clear, then quick, please let me know that also. Okay? Let me know that also. And using this diagram, using this question, I am going to also explain you single slit. Let's suppose this is your screen and this is we have got a single slit by the way over here. Take a single slit. So let's suppose they are saying that we are having first minima at 30 degrees. So first minima at 30 degree. So this angle is, mind you, this angle is 30 degree. This angle is 30 degree. Okay, so here we have got the first minima. So दोस्तों, for first minima, we know that path difference, the formula for path difference is a sine theta. Delta x is a sine theta, and that should be equals to n lambda for minima. Please remember it, this will be for minima. That means a sine 30 is equals to n, that is 1 multiplied by lambda. Multiplied by lambda. Shall I keep value of lambda as 5000? I don't think so. We have got a need for that. Please let me explain it to you. See, from here I'll get a equals to 2 lambda. Because sine theta is 1 by 2. Sine theta is 1 by 2. Now they are saying that first secondary maxima. First secondary maxima. Why they talk about secondary? Because of course central maxima is going to be the primary. First secondary maxima basically means that delta x, that is a sine theta dash, will be equals to 2n plus 1 lambda by 2. So instead of a, let's write 2 lambda. Instead of a, let's write 2 lambda multiplied by sine theta dash, and instead of n, let's put 1. So instead of n, we are putting 1. So this will become 3 lambda by 2. So lambda gets cancels out. Theta dash will come out to be sine inverse 3 by 4. Sine inverse 3 by 4. That means option 4th is the correct answer. Clear, my dear friends? Because of me, you got one question wrong. First question, sorry for that. But now everything is cool. Okay? Fourth is absolutely fine. Very good. Clear. Great. Yeah, pi lens is not working. Yeah, I don't think this is pi lens. Pi lens. Just a second, let me get pi lens here. Maybe many of you are not able to attend the poll because of this thing. Let me get pi lens for you. Okay, just a second, I have informed the in charge. Chalo, by that time, let's move on to the next question. Hopefully, this is absolutely clear. Let's move on to the next question. In this question, they are saying at what surface from the surface of the earth gravitational potential and the value of small g are this, take the radius as this. Chalo, 90 seconds. Let's start, my dear friends. Gravitational potential and value of g. So, gravitational potential is V equals to, if I am going to talk about the magnitude, gmm upon at a height. So, let me write it as r plus h, and magnitude, I am going to talk about magnitude doston. So, 5.4 multiplied by 10 to the power 7. Let's take a look at units. Everything is in SI units, so no worries about that. And value of G. Value of G is written as Gm upon R plus H whole square is equals to, the value is 6. The value is 6, right? Now let's just take the ratio of these two. Simply let's take the ratio of these two, my dear friends. That's it. So when you are going to take the ratio, Gm, by the way, mass is given, mass is not given, right? Acha, potential, for potential we don't have to worry about, potential is per unit mass na, so this will also get cancelled out. So we can cancel out Gm and Gm. This is gravitational potential, not energy, gravitational potential, hai na? See, per kg square. So we are going to simply write it as Gm. So Gm and Gm get cancels out, and now we'll get over here, I'll write it over here for you, 5.4 or R plus H whole square divided by R plus H is equals to 5.4 multiplied by 10 to the power 7 whole divided by 6. Dosto, this is 0.9. This can be cancelled out, and H will be written as 9 into 10 to the power 6 minus 6400 into 10 to the power 3, right? So I can write it down as 9 into 10 to the power 6 minus 6.4 into 10 to the power 6. Is it clear, my dear friends? Yes, from numerical portion you will get more questions, dosto. No doubt about it. Is it clear, dosto? Sorted? Let me know. Is there any trouble? I'm trying to get the pi lengths. Don't worry about it. Hold on. This will be 2600. Yeah, you guys are saying B. Lots of students are saying B. How B is possible, bache? How B is possible? This will become 2.6 multiplied by 10 to the power 6. This is in meters. So this will be 2600 kilometers. This will be 2600 kilometers. Please check your answer again. Many of you are saying 1600. Correct answer should be 1. Correct answer should be 1. Okay, no problem. Most of you think it is B, but let's check. I think everything is done. Gm and Gm gets cancels out. This R plus H square will be in the numerator. One of the R plus H will get cancelled out. Over here we have got 5.4 divided by 6. This is 0.9 or 9 into 10 to the power 6. Radius of the earth is 6400 kilometers. Kilometer means 10 to the power 3 meters. Let's put 3 more zeros. 1, 2, 3. So 6.4 into 10 to the power 6. 9 minus 6 is 3. है ना? And 3 minus 0.4 is 2.6. So 2.6 into 10 to the power 6. Again convert it into kilometer. Right? All right. Any more doubt? Clear? Moving on to the next one, dosto. Please see. Hopefully now everything is clear. 30 seconds. No, chalo, 45 seconds. Out of the following options, which one can be used to produce a propagating electromagnetic wave? Propagating electromagnetic wave basically means they are talking about electromagnetic wave. So a charge moving at constant velocity, no. A charge moving at constant velocity will create electric field and magnetic field. A stationary charge will create only electric field. A chargeless particle will do nothing. Answer is an accelerating charge or vibrating. Same thing. So option D is correct. But still in this one year, some people are thinking that A is going to be the correct answer. Don't do this. Don't do this. Chalo, let's move to the next question. This is a nice problem again. Huh? So pay attention. Nice question. Very good. All clear? That gravity question is all sorted now. Moving on to the next one, my dear friends. In this question, they are saying, first of all, let me read it for you. Then I'm going to give you 90 seconds for this. A uniform rope of length capital L and mass M1 hangs vertically from a rigid support. A block of mass M2 is attached to the free end of the rope. A transverse pulse of wavelength lambda 1 is produced at the lower end of the rope. The wavelength of the pulse when it reaches the top of the rope is lambda 2. You have to find out lambda 2 is to lambda 1. Chalo, be quick. By that time, I'll help you with the diagram. See what they are trying to say. They are saying that from a ceiling, we have got a rod like this, and from this rod we have got a block of mass M2. So this has got mass M1, this thing has got mass M1, and this thing has got mass M2, right? And then they are saying that at lower end wavelength is lambda 1 and at upper end wavelength is lambda 2. So you need to find out lambda 2 is to lambda 1. ठीक है? All right, clear? So for this, you guys need to understand one concept, and that is velocity can be written as, or speed of transverse wave can be written as under root tension divided by mu. Now mu is same. Please note this point that mu is same. Mu is same, but tension is not same. At the lower end, please understand, at the lower end, tension is T2. Tension is T2 and T2 will be equals to M1 plus M2 into G. M1 plus M2 into G. Aha. Tension is only M2G. Tension is M2G. And at the upper end, it will actually bear the total weight. So tension, by the way, this is at the upper end they are saying lambda 1 is produced at the lower end. So this I'm going to write this thing as T1. This is slightly confusing, no problem. This is T1 and this is going to be T2. So T2 is going to be M1 plus M2 into G. Sorted, my dear friends. Clear? Done. Acha, velocity can be written as F lambda. Velocity can be written as F lambda frequency into wavelength is equals to under root T by mu. From this, we can say that lambda depends directly on tension. Lambda depends directly on tension. You can, from now on, you can remember this thing. Okay? From now on, you can remember this thing. Please note, they are saying, please note, my dear friends, they are saying a transverse pulse of lambda 1 is produced at the lower end. So that's why I am assuming T1 to be at the lower end. And T1 is going to be, see, this point will only bear the weight of M2. And this point will bear the weight of this rod as well as M2. This thing is M2. Clear? Done. So now, my dear friends, if somebody is asking you lambda 2 divided by lambda 1, lambda 2 divided by lambda 1, it will be simply T2 divided by T1. And that's going to be T2 is, tension T2 is M1 plus M2 into G divided by, and T1 is M1G. So G can be cancelled out. M1 plus M2 divided by M1, that means fourth option is the correct one. My dear friends, be quick. Let me know if you have any doubt. Is it clear, dosto? Clear, clear, clear? Divided by T1, na? Divided by T1, and T1 was M2. Yeah, T1 was M2. What I am doing? T1 is M2. T1 is M2, bhai. T1 is M2. Here I am writing correct and over there I am not writing correct. T1 is M2. Okay. So T1 is M2, that means option B is correct. T2 is M1 plus M2G, T1 is M2G. So option B is going to be the correct one. Chalo, let's see how many of you have got it correct. Very good here. Very, very nice. Great. Clear? Everything is sorted. हाँ, 2 होगा because this is T1 is M2G. Chalo, moving on to the next question. This is not very difficult. Easy. Let's start. 60 seconds. Let's begin. You only have to find out the current flowing through AB. Current flowing through AB and diode is ideal. Ideal basically means that it will not have any resistance. Okay? Diode is resistance free. No forward resistance. Second is correct, by second is correct. Okay? There were some confusion regarding T1 and T2, but now it's absolutely correct. Be quick. Done. Current will be simply delta V, that means potential difference divided by R. V is 4 volt minus of minus 6 volt divided by R is 1 kilo ohm. Divided by R is 1 kilo ohm, 10 to the power 3. So you will get 10 times 10 to the power minus 3 ampere. That means 10 milliampere. So 10 to the power minus 2 ampere. B is correct. 10 to the power minus 2 ampere. B is absolutely correct. Very easy, very peasy, right? Good. Moving on to the next one. Chalo, this is a nice problem again. Again a nice problem. Let's start. They are saying that the charge flowing through a resistance R varies as this. Varies as this. Where A and B are positive constant, the total heat produced in R is. Let's start. 90 seconds. Let's begin. Nice problem. Please understand. Charge flowing, the rate of flow of charge is given. Sorry, charge equation is given. We need to find out rate of flow of charge. We need to find out current. Come on. Be quick. Be quick. Q is given. You need to find out heat produced in R. So let's say you have got a resistance and some current I is flowing, resistance is R, and let's say for T time. So we know that heat is written as I square RT. But this is, we are going to use this formula when current is constant, right? When current is constant. Right now current is not constant. So we can't use this formula. So instead we are going to use H is equals to integral of I square R into dt. Very important formula dosto. Pay attention. Pay attention. Very, very important formula. I square R dt when current is not constant. But what are going to be the integration limit? What are going to be the integration limit? That's the first point. If you are going to closely see this equation, you are going to observe that, of course, I mean, we can find out the current. We can find out the value of current. I will be simply dq by dt. I will be simply dq by dt, and that will be, this is going to be A minus 2b t. A minus 2bt. See, whenever in physics, any derivative equation, things like this comes na, with a negative sign and time over there. You have seen this thing in kinematics also. And over there also I say here, this means that velocity will become 0 at a particular time. So that means current will also become 0 at a particular time. So let's find out that current. That time, sorry. Let's find out that time when current will become 0. Because see, this is A minus something and this something is increasing with time. That means this current is decreasing. So current will be 0 at current will be 0 at A minus 2bt equals to 0. So that time will be A divided by 2b. So at this time, at this time, current will become 0. Current will become 0. Current will become 0, right? So now let's substitute heat is equals to integration of, now obviously if you are going to integrate this current, you are going to get to this, but fine, let's write it down. So you have got A minus 2bt, but you need to square it, multiplied by R, right? Multiplied by R, value of resistance is R, dot dt, and you need to integrate it from 0 to t, and that value of t is this, A by 2b. A by 2b. Now write down in the chat box if concept is clear. Please quickly write down in the chat box if concept is clear what we have done over here, how you are going to find out the limit. Please understand, after current will become 0, there will be no more heat produced. So if you want to find out the heat produced, we are going to find it from t equals to 0 to a particular time when current will become 0. This is the time till current is flowing, so this is the time till heat will be produced, right? Now let's quickly solve it, my dear friends. We are going to write down, this will become AT and this will become 2b t square divided by 2, and 0 to A divide, acha, by the way, we have got also square of this first here, I'm so sorry, we have to square it first, I square R dt. So let's write it down as it is. This will become A square plus 4b square t square minus 4ab t, right, minus 4ab t multiplied by R into dt. And then again from 0 to a specific time t, I'm not writing that value, we are fine with that. So when you are going to write it down, this will become A square t plus 4b square t cube divided by 3 minus 4ab t square divided by 2, and then limits from 0 to A upon 3b, A upon 2b multiplied by R into t, multiplied by R, and that's it. We have integrated it. Now please solve. I don't have any space, but I'll tell you the answer, and I'll take the doubts also. Quickly let me know in the chat box if you have any doubt till here. Doston, be quick. After integrating it, you are going to get answer A. A cube R divided by 6b. A cube R divided by 6b. That is option 1. Let me know in the chat box. I'll take your doubts. No worries. If you have any problem, please. Done? Done. Option 1. Only 52.63 have got it correct, and other students was thinking it is option 2nd, but it is not. Chalo. Clear? No doubt? Any problem? This is fine, na? After this you guys can do, na? You only have to put, instead of t, you put A divided by 2b. So this will become A cube divided by 2b. Instead of this t, again put A cube divided by cube of 2 and b cube. So b will get cancelled out and you will get to the correct answer. ठीक है? Chalo. Moving on to the next one, my dear friends. Let's solve this one. Two charges, each of magnitude capital Q, are fixed at a distance 2a apart. All right. So we have got two fixed charges. And these are Q and Q, and these are at a distance of 2a apart. A third point charge minus Q is placed at the midpoint. So third point charge minus Q is placed at the midpoint of the two charges. Now minus Q is displaced in a perpendicular. That means it is displaced in this direction. It is being displaced in this direction. Find out the time period. 90 seconds. Let's start. So let's suppose we have displaced it to a distance, a displacement of x. So let's say this is x, right? And then you have to find out. Come on, be quick. Please note, this is a, this is a. So this distance is going to be a square plus x square, and root of it. This distance will be a square plus x square and root of it. Clear? Right? And forces are going to act somewhat like this. By the way, please remember, we have got a minus q charge over here. We have got a minus q charge over here. So there will be attractive forces. So let's say these are the attractive forces. Clear? Alright, dosto. If you guys want, we can assume this angle to be theta. Now we can assume this angle to be theta, or if you guys want, we can assume this angle to be theta. It depends upon you. So if this angle is theta, please note, you are going to have one of the component of force like this. You're going to have another component like this. And if this angle is theta, then this angle will be theta and this angle will be theta. So these forces will get cancelled out, and you're going to have a downward force on this charged particle, two downward forces. Something like this, and that's why it's in stable equilibrium. Got it? So the net force will be written as, the net force will be written as 2f sine theta, or I can write it down as 2f will be written as kqq divided by square of the distance. Square of distance means x square plus a square multiplied by sine theta, and sine theta is, by the way, dosto, x divided by a square plus x square whole raised to the power 3 by 2. Now this is where the interesting thing starts, and this is all a very standard type of questions. You might have seen these questions in your class notes, right? See, F-net comes out to be, by the way, one more thing, they have used one word over here, that is, it is slightly displaced. Slightly, whenever somebody is going to tell you that it is slightly displaced, that means x is far more less than a. X is far more less than a. So in the next step, we are going to write that the net force can be actually written as 2kqx divided by x square plus a square whole raised to the power 3 by 2, and then I can say here this x square can be considered as 0. For a simple reason, x square can be considered as 0 for a simple reason, because x is far more less than a, right? So you are going to then get, please see, you are going to then get 2k capital Q small q times x whole divided by, this will become a cube. This will become a cube, right? And I can see answers in pi epsilon naught, so I'll get rid of this k. See, then I'm going to say that acceleration, net acceleration can be written as, instead of k, let me write it as 1 upon 4 pi epsilon naught, and then you have got capital Q small q divided by a cube and a mass and x. So if you are going to now compare this thing, if you are going to compare this thing with acceleration, so acceleration can be actually written as minus omega square x. See, I'm not really worried about the negative sign. I was just talking about the magnitude, but you guys can see that we are displacing it in this direction, and net forces are acting in downward direction. By the way, both of the magnitude of those arrows are going to be same. I mean, the length are going to be same. So don't assume anything else. Okay. So having said this, now we can compare omega with this. This is omega. And by the way, you can also cancel out this 2. So omega will come out to be, I've got less space, no worries. Omega will be small q capital Q divided by 2 pi epsilon naught a cube times m. This is omega. So time period will be 2 pi by omega. 2 pi by omega. Acha, by the way, this is not omega, this is omega square. So omega is going to be under root of this, right? So if you are going to put 2 pi and under root, so in the denominator you have got 2 pi epsilon naught, and by the way they were talking about time period na, so everything is fine. 2 pi epsilon naught a cube m divided by small q into capital Q. So lots of things to do. 2 pi epsilon naught m into, I think B option is absolutely correct, right? Clear dosto? Quickly let me know in the chat box. It was a slightly lengthier problem, but we have solved it. Very good, very nice. Any doubt in this? Can we move on to the next question? B is absolutely correct. You guys can see, after this step I have equated, I have actually said that acceleration can be written as minus omega square x, and then simply compare these two equations. So omega square will be equals to this, that means omega will be under root of this. ठीक है, moving on to the next question दोस्तों. Hopefully everything is clear. चलो, let's see this one. Quick. Sir, A5 होगा. Okay, let's check. A5 नहीं होगा बच्चे. This is a cube. You can see over here also. This will become a square, and this will cancelled out with this root. So this will become a cube. है ना? For sine theta, I have written perpendicular x divided by base. So this is absolutely fine. Next question. Next question is coefficient of linear expansion of brass and steel are alpha 1 and alpha 2. Length of brass and steel rods are alpha 1 and L1 and L2. If L2 minus L1 is maintained same at all temperature, which of the following relations hold good? Chalo, let's find it out. 90 seconds. Come on. Quick. Next question. Be quick. Solve this particular problem. From coefficient of thermal expansion. Be quick. They are saying coefficient of linear expansion of brass and steel rods are alpha 1 and alpha 2. Length of brass and steel rods are L1 and L2 respectively. ठीक है. If L2 minus L1 is maintained same at all temperatures, right? At all temperatures, which of the following relations hold good? Please understand what do they mean by that? L2 minus L1. L2 minus L1 is maintained same at all temperature. That means L2 minus L1 is constant. Right? It is maintained same at all temperatures. This means that delta L1 is equals to delta L2. Please understand what they are trying to say. They are saying that if we have got a rod of let me remove all of these things, you will get confused. Let's suppose if we have got two rods, one is of let's say brass and another is of steel, है ना? One is of brass, this one is of brass and this one is of steel. Let's say their length are also different. Let's say this is L1, this is L2. And let's say this is at any temperature T0. So this is the change in length. This is the L1 minus L2. Now they are saying that this will remain same. At all temperature, this remains same. this L2 minus L1 remains same. That means if let's suppose after any temperature brass extends by some unit, then the second rod should also extend by the same units, else L2 minus L1 will change. So we have to keep this constant, which means that delta L1 and delta L2 must be same, and delta L can be written as alpha into L1 into delta T is equals to alpha 2 into L2 into delta T. So delta T and delta T will get cancelled out, and alpha 1 L1 is equals to alpha 2 L2. This will be the answer. Very easy, but please understand the concept. Very good. Any more doubts? You write down in the chat box. Everything's clear, write down in the chat box, my dear friends. Then moving on to the next one. Moving on to the next question. Quick. Let me know. Clear? Sorted? Friends? Chalo. Now let's move to a question of first let's solve this problem. An electron of mass m and photon have same energy E. The ratio of de Broglie wavelength associated with them is 60 seconds. Let's start. First they are talking about electron. First they are talking about an electron of mass m and they are talking about photon. Whenever they are going to talk about electron, use the de Broglie wavelength formula as lambda E is equals to h divided by momentum, and momentum can be written as 2m ke. Instead of ke, let's simply write down ke, because they have said that energy is E. Clear? Energy is E. Clear? Next is they are saying for photon also. So for photon, dosto, energy is E. So E can be written as hc by lambda of photon. So lambda of photon from this formula can be, we can write it down as hc divided by E. hc divided by E. Here. So after hc divided by E, let's equate it. We have to find out the ratio of them. So first they were talking about lambda of electron, then lambda of photon. So it is going to be h divided by under root of 2me, and this will become hc divided by E. So h and h will get cancelled out, and dosto, I guess what you can do is you can rewrite this thing as you have got c out from this and under root of E divided by 2m. You can cancel out this root with this E and you will get something like this. So 1 upon C under root of E divided by 2m. Option second. By why? Huh? Where will that C will go? Option 1 is correct. You're saying with so much of confidence C is correct. Option 1 is correct. Okay? Please let me know in the chat box. This is very easy. Option A is absolutely correct. Good. Very good. Clear? Done? Can we move on to the next question? Chalo. Next question is this. The particle executing SHM of amplitude A has displacement minus a by 2 at t by 4 and positive velocity. Find the initial phase of the particle. Chalo, let's see if you guys can do this question. The particle executing SHM of amplitude A has displacement minus a by 2 at small t equals to capital T by 4, right? And you have to find out the initial phase of the particle. Well, I have always said that whenever you want to solve a question of these kinds, you can use the projection method. By projection method, I mean to say, let's suppose we are taking projection of a circular motion and that projection will look like a SHM. So the particle is at displacement of minus a by 2. So bache, minus a by 2 is somewhere over here. and it has got positive velocity. That means positive velocity means it is moving in this direction. That means the particle is at this point. Particle is at this point, dosto. Clear? Please understand. The important point over here is that they are saying displacement is minus a by 2. So this is a, this is x equals to 0. This is x equals to minus a amplitude. This is x equals to plus a. So minus a by 2 will be somewhere over here. Minus a by 2 will be somewhere over here. Now particle can either move in this direction or in this direction. Now they are saying, in the next line they are saying that and a positive velocity, and a positive velocity. Positive velocity means it is moving in this direction. So that means particle is somewhere over here at this point and it is moving in this direction, right? So I'm going to draw the velocity like this. Now the thing is, we actually, when we say that phase is 0, initial phase is 0, then we say that particle is moving something like this, which means that's from here, right? Is it clear, my dear friends? So just a second, let me make some changes. This particle is not going to be at this point, this will be at this point. Let me extend it. This particle will be at this point, dosto, at this point, because it is moving towards the mean position. It is moving towards the mean position, right? So it will be somewhere over here. So this is going to be the initial phase. This is going to be the initial phase. This is going to be the initial phase, dosto, phi. How to find that one out? I'll tell you. Dekho, this is very simple. We know that this is a by 2. The length is a by 2. This length is a. This length is a. So this angle will be 30 degree. Is it clear? Sorted, my dear friends? Please see. This length is a by 2. This length is a. So this angle will be 30 degree. Sine 30 degree is perpendicular divided by hypotenuse. So if this is 30 degree, my dear friends, this angle is going to be 60 degree. This angle will be pi by 3. Acha, this angle is 3 pi by 2. This angle is 3 pi by 2. So initial phase is going to be 3 pi by 2 plus pi by 3. 3 pi by 2 plus pi by 3. So into 2 and into 3 and into 3, or you can actually 3 pi by 2 is basically, this is absolutely correct. It was moving in positive x direction, na? This is absolutely correct. So this is going to be 5 pi by 6. 5 pi by 6. Acha, into 3 into 3. So this will be 9 and 11. We are getting wrong answer kya? Just a second. Let me see. This thing is pi by 6. This thing is pi by 3. So this is pi plus pi by 2 and plus pi by 3. So this will be 3 pi by 2 plus pi by 3 into 2 into 2 into 3 into 3. Just a second, dosto. Let me check why we are not getting the correct answer. They have also said that it is at t by 4. Okay, no problem. Let me use another method. No problem. They are saying at t by 4. This is not at t equals to 0. This is the problem. So that means let's use another method. X is equals to a sine omega t plus phi. So x is equals to minus a by 2. This is equals to a sine and omega is 2 pi by t. ठीक है, और चलो that we'll find out. This is omega t plus phi. So this gets cancels out. That means sine of omega t प्लस phi is -1/2. ठीक है, अब -1/2 साइन विल गिव अस -1/2 at this point, ठीक है, that means after 180 degree, and it will be pi plus pi by 6, ठीक है ना, and then let's find out the value. So omega t plus phi is equals to, and this value is going to be दोस्तों 7 pi by 6, and then put the values 2 pi by capital T, and now put the value capital T by 4 plus initial phase phi, and that will be 7 pi by 6. So finally we will get phi as, this T and T will get cancelled out, this will become pi by 2, so this will be 7 pi by 6 and minus pi by 2, so into 3. So finally दोस्तों we'll get our answer as 4 pi by 3. Second is the correct answer. नहीं, first नहीं बच्चे, second is the correct answer. Use this method here. See, the problem in this method was that I actually completely missed this fact that they are talking about t by 4. This method is absolutely fine, but I was actually calculating it from 0. I thought that at t equals to 0, this particle is at over here. That's why I was measuring this complete angle. Okay, that's not true. They are saying that at t by 4, particle is at minus a by 2. Okay, na? Clear? Is it clear, my dear friends? This method is absolutely correct. But right now they are talking about t by 4, so you can use your general method. That is x is equals to a sine omega t plus phi, and for a moment you can consider this entire angle to be some angle theta. So let's write minus a by 2 is equals to a sine theta. Let's write it like this. Theta, a and a gets cancels out. Sine theta will come out to be minus 1/2. Now we can know at what angle sine theta will give us minus 1/2. It will give us somewhere over here, because till 180 degree it doesn't give negative value, है ना? Sine curve moves like this, so it will give at somewhere over here, and this will be pi by 6 only. So this angle will be pi plus pi by 6, so this will be total 7 pi by 6. So put the value over here. Instead of theta, 7 pi by 6. So theta was your omega t plus phi. And now instead of omega, write 2 pi by capital T, and instead of small t, write down this value, capital T by 4, and plus phi, and then you can write down that value. Got it, my dear friends? Clear? Is it clear? Any doubt in 7 pi by 6? Let me know. Done? B is correct. Good, very good. B is correct. Chalo. Nice problem. Just because of this t by 4. So, I mean, if it was not t by 4, then you could have used this method. Okay. Let's see the next question. The angle of incidence for a ray of light at a refracting surface of a prism is 45 degree. Okay. So refractive prism, it is 45 degree. The angle of prism is 60 degree. Fine, angle of prism is 60 degree. The ray suffers minimum deviation through the prism. Dosto, hopefully you remember the conditions and formulas for minimum deviation. Okay. Sir, in de previous questions, can we use E equals to MC squares? No, bachche, that is not required. For that de Broglie wala question, no, please don't use E equals to MC square. Through the prism, the angle of the minimum deviation and refractive indexes. Chalo, start. Come on. You have to find out the angle of incidence for a light at a refracting surface is 45 degree. Theek. First of all, they are saying the angle of incidence is 45 degree. So let's assume it over here. This angle is 45 degree. And they are also talking about what is the refractive index of the prism. So we don't know what the refractive index of the prism is. Okay? But we know some conditions of minimum deviation. And that are कि दोस्तों R1 and R2 are same and that is equals to A by 2. ठीक है, R1 and R2 are same and that is equals to A by 2. That means when ray of light will pass from here and then they are saying that it suffers minimum deviation, then these are R1 and R2. This is R1 and this is R2. And by the way, because they are same, so this angle is also same, 45 degree. ठीक है, so angle of deviation is basically I plus E minus A. So this will become 2I minus A. ठीक है, alright दोस्तों, this will become 2I minus A. And they are saying, so this will become 2 times of 45 degree minus angle of prism is I believe 60 degree. So this the answer will become 30 degree. Chalo, half answer I have told you. Quickly write down in the chat box. Next is finding out the mu. So sine of A plus minimum angle of deviation divided by 2 divided by sine of A by 2. Simply use this formula. So sine of दोस्तों A plus del minimum. A was 60 degree, del minimum is 30 degree. This will become sine 45 degree divided by sine 30 degree. So this will be 1 by root 2 and this is going to be 2. So this will be root 2. That means second is the correct answer. Second is the correct answer दोस्तों, B. Why? What has happened bhai? Please check once. Please check once. Is there any trouble? Second is the correct answer here. Why you guys have said third? Huh? So there is no problem in root 2. So how you got third? How you got 45 degree here? See this calculation. See this calculation and ask me if you have any doubt. Please let me know. Quick. Any problem in this question? Clear hai? Done. This is absolutely correct. Chalo, moving on to the next question. When alpha particle of mass m moving with velocity v bombards on a heavy nucleus of charge Ze, the distance of closest approach. Very easy. Distance of closest approach. ठीक है, let's start. 60 seconds. It's not lengthy. Alpha particle is moving with a velocity v on a heavy nucleus. So we have got a heavy nucleus somewhere over here. You have got alpha particle at this point. And you have got heavy nucleus over here. That is Ze plus Ze. ठीक है, so distance of closest approach. So let's suppose it has got some velocity v. That means right now it has got kinetic energy half mv square. Half mv square. This is the kinetic energy, right? And at a particular point, this entire kinetic energy will get converted to potential energy and it will become at rest. Let's suppose this separation is r. So we are going to simply say that this entire kinetic energy will be equals to half mv square is exactly equals to k q1 q2, that is Ze multiplied by alpha particle is 2e and divided by r. Clear? दोस्तों, kindly see if you have any doubt. So as I can see that we have got m over here and we have got r, so there is an inverse relation. Other than that, everything is a constant. Please see, v is constant. They have given us k, z, e, all of these things are constant. So m is inversely proportional to r or r is inversely proportional to m, whatever you want to call. Okay? So 1 upon m is the correct answer. A. Chalo, good. Again, let me ask you, hopefully no problem with this. Why almost all of you have said C? Is there any trouble in this question? Clear? Can we move on to the next question, dosto? Quickly let me know. Can we move on to the next one? Be quick. Let's see this particular problem. The molecules of a given mass of a gas have RMS velocity 200 meter per second at 27 degrees Celsius and this pressure. When the temperature of the gas are respectively 127. Chalo theek hai, let's solve this question. 60 seconds. Come on. Let's solve this one. No, please, if you have any doubt, ask me. Come on, let's solve this particular problem. They are talking about VRMS. For VRMS, you guys can use the formula under root of 3 RT by M. RT by M. So they have given you VRMS, and from here you can know that VRMS is directly proportional to under root T, under root temperature, right? When the temperature of the pressure, so I mean, let's not use the pressure, right? When we are going to use this formula, we actually don't require pressure. So we are not going to use this information. Okay? Although we can actually derive that formula also from this and you also remember, but fine, for that we'll have to write down density also, and that is not given. So let's not get into that. What we are going to do is we are going to simply use this concept, and then we are going to say that V2 upon V1 will be equals to under root of T2 upon T1, and under root of T2 will be, dosto, this is 127, right? So 127, T2 is going to be 273 plus 127, got it? So this will be 10, 10, 400. So this is the 400 Kelvin, and that is 200 Kelvin, 300 Kelvin, right? So 0 and 0 gets cancels out. So V2 will be 2 root 3 multiplied by V1, and V1 is 200. That means answer will be 400 by 3 meter per second. 400 by 3 meter per second. That means option B. Chalo. At least now you guys are back. Hai na? At least now you guys are back. Please see. Next, moving on. You have to find out velocity of center of mass. You have to find out velocity of center of mass. The velocity of center of mass of the entire system is 90 seconds. Let's start. Let's start, dosto. You have got 1 kg moving with 2 meter per second. You have got 2 kg moving with 2 meter per second at an angle of 30 degree from the x-axis in downward direction. Chalo, be quick. What's going to be the answer for this one? We have got many questions here. We have got many questions to solve. Aditya, how many questions are there, sir? There are many questions, bache. I don't know, maybe 100, 150 questions, between 100 and 150. Be quick. Let's solve this question. We are going to use the concept of velocity of center of mass, and that will be m1 into v1 plus m2 into v2 whole divided by m1 plus m2. Whole divided by m1 plus m2, right? So first of all, let's write down v1 as v1 velocity is actually 2 meter per second I cap. 2 meter per second I cap, and v2 velocity can be written as, now please pay attention, v2 will be written as 2, this will be written as 2 sine 30, and this will be written as 2 cos 30. So we are going to have 2 cos 30, and instead of cos 30, I can write down root 3 by 2 I cap and minus 2 sin 30 j cap. So 2 and 2 gets cancels out, 2 and 2 gets cancels out, and we have our V2. Now doston, let's substitute it in our formula. So we'll get VCOM equals to, in vector form, and by the way M1 has mass 1 kg, so 1 multiplied by 2 I cap, right, 1 multiplied by 2 I cap plus M2 is 2 kg and V2 is root 3 I cap minus j cap whole divided by 3. So doston, if you'll ask me, let's write down I cap together. So we are going to write 2 plus 2 root 3 divided by 3 I cap minus 2 by 3 j cap. So answer 2 plus minus, this is wrong. I think this option is absolutely correct. Chalo, option second clear. Any doubt, my dear friends? Quickly let me know. Option B. Very good. Chalo, I'm glad now you guys are again giving right answers. Very good. Aditya, stop talking and start solving. Quick. Chalo, moving on to the next one, my dear friends. 3 rings each having equal radius. So you have got 3 rings, huh? So one of the ring is like this, another ring is like this, and another ring is like this. Okay? These are placed mutually perpendicular to each other, each having center at the origin of coordinate system. If I think they are saying if current I is flowing through each ring, then the magnitude of magnetic field at the center, at the common center is. Chalo, let's start. Nice problem. Be quick. Quick. हाँ, please ask your doubt, Mahira. Please ask your doubt. Please ask whatever doubt you have. Come on. See, let me explain this to you. Let's suppose if you have got a ring like this, okay? If you have got a ring like this and current is flowing in this ring, something in this manner. In this manner. So, or in any direction here. If current I is flowing in each ring, okay? We have to find out the magnetic field, correct? So if it is flowing in this direction, magnetic field will be in this way. If let's suppose magnetic field is flowing in this direction, current is flowing in this direction, then magnetic field will be over here. So due to one ring, magnetic field is in this direction. Let's just suppose, okay, although they have not given us the direction of current, this is because of course this ring. I'm going to color code it for you because of this ring. Fine, my dear friends. And let's talk about this ring now. Let's talk about this ring now. Kindly see this ring. If let's suppose current is moving in this direction anti-clockwise, magnetic field will be upward. Magnetic field is going to be in upward direction. So this is magnetic field B, magnetic field B. And dosto, if again current is moving in anti-clockwise direction for the last one in something like this, then magnetic field will be outward to the board. So I won't be able to draw it, but hopefully you guys can understand it. This is going to be this B. Is it clear, my dear friends? Is this absolutely fine? Alright, so now I don't need this ring. So net magnetic field will be written as under root of 3b square. B square plus B square plus B square, or we can write down B root 3. And this is mu naught I upon 2R times root 3. So mu naught I upon 2R times root 3. Option A is correct. Sorted, my dear friends. Option A is correct. Clear? Done? Quickly write down in the chat box. Please see. So what you need to understand over here is that three rings having equal radius, mutually perpendicular. So its current is I flowing through each ring, then the magnitude. So we'll have to assume that it is moving in any particular direction, and then we can find out the question, find out the answer. ठीक है, चलो moving on to the next one now. Moving on to the next one. One more question related with magnetic field. Nice problem. नहीं समझ में आया? Shall I explain it again? Okay, no problem. I'll explain it again. See, the question says that you need to find out the resultant magnetic field. Now, magnetic field are in the mutually perpendicular direction. Rings are also perpendicular. Magnetic field is also perpendicular. B, and the third magnetic field is like this, coming out of the board. Right? So you have got one of the field like this, another field like this, and another field like this. So to find out the net magnetic field, we have used the formula, the basic formula, B net equals to under root of Bx square plus By square plus Bz square. Now all of them have same magnitude because radius is same, current is same. That's why I have written 3 times of B square. Abhi to I have explained everything here. Chalo, now let's solve this particular question. This is also a nice question. Okay, you need to find out magnetic field at center C, at point C. Let's start. 90 seconds, let's begin. You have to find out magnetic field at center C. Come on. Start. To solve these types of problem, first of all, mark the number of elements. So you have got one current carrying, you have got one straight current carrying wire over here, and it is a semi-infinite wire. This one is the first one is semi-infinite wire. And so semi-infinite wire and magnetic field at this point. Okay? So magnetic field will be outwards. So due to this wire, magnetic field will be outwards. Now then we have got another segment which is a semicircular ring. And due to this also magnetic field is outwards. And then again, my dear friends, then this is x-axis, please note, and then you have got current over here. Another current carrying conductor over here, straight current carrying conductor. Then again this is semi-infinite wire. Clear, doston? Hopefully everything is sorted till here, hopefully. So now to solve this, first of all, let's understand the directions. Net magnetic field will be, I'll write down the net magnetic field in vector form will be magnetic field due to element 1, due to 2 and due to 3 vectorly. You need to add them. So this is 1, this is 2 and this is 3. So because of one, magnetic field is outwards, and outwards basically means, my dear friends, this is x, this is y. Outwards means k cap. Outwards means k cap. So instead of B1 we are going to write mu naught I upon 4 pi, and this is going to become r by 2. This is really important because this complete distance is r. So this distance will be r by 2. So this will become r by 2, and this will be in k cap. This will be in k cap. Clear? So chalo, let me write it like this here. Let's say कि this is B1, है ना? This is B1, so that I can have some space. This is B1 and this can be cancelled out. So finally we are getting B1 as mu naught I upon 2 pi r, and this is in k cap. So if you have got k cap, fine. Now let's talk about B2. B2 is, bachcho, it is like this. Current moving in this way, current moving in this direction, thumb pointing outwards. Current moving in this direction, thumb pointing outwards. That means magnetic field will be again in k cap. Please remember, this is x axis, this is y axis, this is on xy plane. So magnetic field will be perpendicular to xy plane, that is k cap. So again we are going to write mu naught I upon 4r, and now again for radius let's write it down as r by 2, and again k cap. So this will become 2, and finally you will get mu naught I divided by 2r, and this is in k cap. So first of all, this can't be correct because here we have got minus. Either it's going to be this, this, or this. Now let's talk about this one. Now this is very important. See what's happening. You have got a point over here. We need to find out magnetic field over here, and current is passing like this. You have to do it. You have to do it right now. Okay? So you have to find out magnetic field over here, and current is passing through like this. So current is over here, and we need to find out magnetic field over here. So we are going to open our fingers like this. Clear? Please quickly see, my dear friends. Hopefully you don't have any doubt. Done? So current in you can actually understand like this. Let's suppose current is moving in this direction. Current is moving in this direction, right? And we have to find out magnetic field at this point. So what we are going to do is, we are going to put our fingers like this, and we are going to open it. It will be along I cap. It will be along I cap, and magnetic field will be written as B3 will be written as mu naught I upon 4 pi, and again the distance is going to be r by 2, and this will be along I cap. So this will get cancelled out, and you just have to add them now. You just have to add them. So I think mu naught I upon, I can take out 2 pi r common. So if I'll take 2 pi r common, I'll get 1 plus pi and minus plus I. So option 1 should be the correct answer. Clear, dosto? Quickly repeat. Quickly, let me know in the chat box. Done? Done? Find the answer. Just add them. You only have to now add them and arrange to find out B net. So if you are going to note, I don't need this right now. If you are going to write down B1 plus B2 plus B3, so B net will become B1 plus B2. So mu naught I, and see what they are taking common, mu naught I upon 2 pi r. So mu naught I upon 2 pi r. So in the first bracket, we'll get k cap. In the second one, we don't have a pi over here, so I'll have pi k cap. Okay? And in the third one, I have got plus I cap. I have also got pi, so I've got plus I cap. So you will have mu naught I divided by 2 pi r, and then you will have 1 plus pi times k cap plus I cap. Chalo. Clear दोस्तों? Let me know. Done? So option 1. Moving on to the next one. क्या भाई? Is it B? Somebody is saying C also. C, for C and B, what's the difference? Acha, B to can't be true here, because if you are going to take 4 as common, it won't be possible. So this won't be possible, hai na? Then some people are also saying this. So let's check once. No, I think it's fine. It can't be 4. It can't be 4. It has to be 2. It has to be 2. ठीक है? It has to be 2. Please see. चलो. Moving on to the next question. Moving on to the next question. Clear? नहीं बेटा, B कैसे होगा? B कैसे होगा? Sir, B3 is negative x-axis. Sir, B3 will be negative x-axis. B3 will be in negative x-axis. Okay, let me check it again. देखो, some students are saying that this is going to be 4 pi r, है ना? If it was 4 pi r, then we won't be able to get this value. So that is certain कि B is not correct. B is not correct, right? B is absolutely not correct, and that makes 4 also incorrect. Now you can also check the direction using Biot-Savart's law. Biot-Savart's law basically says, I'm going to write it down for you. dB is equals to mu naught upon 4 pi I dl cross r upon r cube, right? So dl is in k cap and r is in j cap. Higher, sorry, this is in I cap. This is in negative I cap. Correcto. Major correction, major correction. This is in plus, this is in minus I cap. Good. This is in minus I cap. But still, 4 is not, 4 can't be the answer. Third is the correct answer. This is, use this. Correct. Whoever has said, please tell your name. Please tell your name. Very good. Very good. This is the correct answer. Third is the correct answer. Minus I cap. Minus I cap. B3 will be negative. B3 will be negative. We have checked it using Biot-Savart's law. Okay. Chalo. You can also check it, like for example, as if you have got current in this direction and you need to find out magnetic field over here, right? Magnetic field at this point. So what we do is we write down current over here, we write down magnetic field as cross. Okay. So let's suppose this is J cap and this is I cap. So our magnetic field is coming in K cap, minus K cap. Magnetic field is coming in minus K cap. So what, using Biot-Savart's law, you can write down mu naught upon 4 pi I dl cross r divided by r cube. So dl over here, that means the current element is in J cap cross r is in I cap, right? So J cap cross I cap, again I cap, J cap, K cap. So J cap cross I cap will be in minus, because you are moving in anti-clockwise direction. Okay? So this will be in minus K cap correctly. So we have used the same thing. This current element is in K cap, current element is in K cap, and your R vector is in J cap. So K cap dot J cap is minus I cap. Absolutely correct. Clear? Now everything's fine. Any doubt, dosto? Moving on to the next one. Chalo, two wavelength of lights lambda 1 and lambda 2 are sent through a Young's double slit experiment simultaneously. Chalo, this is not that difficult. 60 seconds will be more than sufficient. Let's start. You have got two wavelength, lambda 1 and lambda 2, and these are used for a YDAC simultaneously. If third order bright fringe coincides with fourth order bright fringe lambda 2, then you have to find out the answer. Quick. Any doubt from the last question? Be quick. third order bright fringe means 3, and by the way they are saying third order bright fringe coincides with the fourth order bright fringe. ठीक है, तो 3, and over here write down lambda capital D by small d, lambda 1 is equals to 4 fourth order lambda 2 capital D by small d. This gets cancels out and they are talking about lambda 1 upon lambda 2. So this is 4 divided by 3. That's it here. Very simple. 4 divided by 3. Very, very easy. Very good. In the figure, the intensity of waves arriving at D from two coherent sources is 2I0. अच्छा ठीक है. So 2I0. The wavelength of the wave is lambda. That is 8 meter. The resultant at D will be. Chalo, let's solve this. 60 seconds. Come on. Be quick. Come on. In the figure, the intensity of waves arriving at D from two coherent sources. From two coherent sources is this. By the way, we can easily find out this S2D using, this will be 36 plus 64. That means this will be 10 meters and path difference will be S2D minus S1P. That means this is 10 minus 8, that is 2 meter, right? This is 2 meter, and if this is 2 meter, dosto, the relation between phase difference and path difference is 2 pi by lambda multiplied by delta x. 2 pi by lambda multiplied by delta x. So you are going to get del phi is equals to 2 pi by lambda. Lambda can be written as 8 and resultant intensity at D na, ठीक है, no problem, we'll find it out. Delta x is coming out to be 2. So this will become pi by 2. This will become pi by 2. Clear? This will become pi by 2. And net intensity will be, दोस्तों, when you have got coherent sources, right? When you have got coherent sources, what we do is we use a formula of 4I0 square cos square pi by 2. But in this case, na, there is one change. That changes, bachcho, that changes that those two coherent lights are not of intensity I0 but 2I0. So instead of this 4I0 square, we'll have to change something, and that change is going to be, we are going to write down 4 into 2I0 and square of this and cos square pi by 2 and multiplied by 2. Please see. Got it? Now find the answer. Quickly. Dosto, find the answer. Be quick. Or you can use the normal intensity formula also. We have got no problem with that also. Hai na? That means I1 plus I2 plus 2 under root I1 I2 cos phi. Clear? Right? Quickly let me know the answer. Dosto, any doubt? Please see, this is very simple. All we have done is, we have said that if at this point we need to find out net intensity, first of all, we'll need to find out phase difference. For phase difference, we have first found out path difference. And path difference is simply going to be S2D minus S1D. Clear? Done, done, done. S2D minus S1D. Now the point is, they are saying that in the figure, the intensity of the waves arriving from two coherent sources is 2I0. Acha, they are saying that it is 2I0. The resultant intensity at D will be, two coherent sources is 2I0. In the given figure, intensity is, the wavelength is 8 meter, resultant intensity at D will be, just a second here, from two coherent sources is 2I0. हाँ, तो that's what they are saying ना. This is I0, this is 2I0 and this is 2I0. Okay, fine. If we are going to check this, if you are not going to use this, and we are going to write down 4I0 cos square. So what I have written initially, अरे भाई this is square तो वैसे भी नहीं होगा. Why we have put square? So initially if you are going to write down 4I0 cos square pi by 4. So you will get 4I0 and cos square pi by 4 will be 1 by 2, right? Or if you are going to put this, you are going to get 4 times of 2I0 and you will get 1 by 4. That means 4 and 4 will get cancelled out and 3 will be, sorry, I have by mistake I have written square over there. Okay, so this is going to be the answer. Clear? 2I0 is the correct answer. Please see, if you have any doubt, do let me know. Very good, very good. Chalo, moving on to the next one. Next is this. The diode used in the circuit shown in the figure has a constant voltage drop of 0.5 volt at all currents. This is a nice problem. You will have to use concepts of both current, electricity and a little bit of diode. And then they are saying maximum power rating is also given 100 milliwatt. What should be the value of resistor R connected in series with the diode? Chalo, let's solve this under 90 seconds. This point is very important. They are saying a constant voltage drop of 0.5 at all currents and a maximum power rating of 100 milliwatts. This is very important. So maximum, if somebody tells you that something has a maximum power rating, so you can find out the maximum permissible current from that. From this information, you can find out the maximum value of current. So maximum value of current will be found out from the formula that power is equals to V multiplied by I, right? And they are also saying that diode is used in the circuit has a constant voltage drop of 0.5 volt at all currents and a maximum power rating. So my dear friends, power rating is this and constant voltage drop is of this. So I max will be power divided by voltage. So power is 100 milliwatt, 100 into 10 to the power minus 3 and divided by voltage is 0.5. Voltage is 0.5. So dosto, one more 0. So this will get cancelled out. Okay. And you will get your answer as 1 divided by 5, that is 0.2 ampere. So this should be the maximum current. Please understand, this is the maximum current that we can use. This is the maximum current that we can use in this circuit. Okay, 0.2 ampere. Now after this, they are saying that 0.5 volt has to be given to this diode. So that means remaining 1 volt will be given to this. And we can, now we also know what is the maximum value of current. That is 0.2. So now they are saying, what is the value of R? So value of R will be simply V divided by I. So V is 1 volt and I was actually 1 by 5. I was 1 by 5. So 5 ampere is the 5 ohm is the correct answer. Please check. I can also rewrite this thing as 1 by 5 ampere. Okay, so 5 ohm is the correct answer. B option. Correct, dosto? Is it clear? Be quick. Done. Sorted. 5 ohm is the correct answer. That is B option. Very good. Only one student was able to solve this. Chat is not working. Kya? Poll is not working in chat. Let me know. If you have any doubt in this question, please ask. Else I'll move on to the next question. Come on. Let's solve this one. A gas is compressed isothermally to half of its initial volume. The same gas is compressed separately through an adiabatic process until its volume is again reduced to half. Chalo, theek hai. 60 seconds is more than sufficient. 60 seconds is more than sufficient. Please remember, they are talking about comparing an isothermal reaction, isothermal process with an adiabatic process until volume becomes half. Poll is not working, kya? So I can ask again, check poll. If you want to compare adiabatic and isothermal, you must remember that slope of adiabatic is greater than the slope of isothermal. Right? So, compressing the gas through adiabatic process will cover more area. I mean, when you are going to draw the graph, because it has got more slope. So, compressing the gas through adiabatic process will require more work to be done. Very easy, 60 seconds was more than sufficient. Here, there is some problem with the chat, I believe. Else, you guys can give me more answers. Chalo, one more question from astronomical telescope. This is also a nice problem. Let's start. 60 seconds. An astronomical telescope has an objective eyepiece of focal length. Acha, theek hai. So this is 40 centimeter. FE is 40 centimeter. Fine. And then they are saying that, and 4 centimeter. So FE is 4 cent. FO is 40 centimeter. Sorry. FO is 40 centimeter and FE is 4 centimeter. And then they are saying to view an object 200 centimeter away from the objective. So kindly see what they are trying to say. They are basically saying that we have got an objective focal length over here. And let's suppose you have got an eyepiece at this point and an objective focal length at this point. Okay. So object is at 200 centimeter. Object is at 200 centimeter. Its image will be obtained, let's suppose, somewhere over here. Right? Now, if they are not talking about anything, if they are not talking about anything, we are going to assume normal adjustment. You are going to assume normal adjustment. Right? That means this is, please understand, this distance is VO. Right? This distance is VO. And this distance should be FE. If let's suppose this image happens to be at the focal plane of at the focus of the eyepiece, then final image will be at infinity and it will be a case for normal adjustment, right? So let's find out VO first. So you are going to use 1 upon FO is equals to 1 upon V plus 1 upon U. So 1 upon minus 1 upon U. Minus 1 upon U. So 1 upon V will be 1 upon focal length, and that is 40 centimeter, and this will become plus and then minus 200. So 5 and this will become 4 divided by 200. That means 1 upon 50 centimeter. So VO comes out to be 50 centimeter. So doston, this is 50 centimeter and this is 4 centimeter. So they are saying the lenses must be separated by, so lenses must be separated by mod of Fe plus mod of VO. So that means 54 centimeters is the correct answer. Please see. Any more doubt, my dear friends? Clear? You're giving answer as A. No, A is not correct. Done? Be quick. D is correct. Somebody is saying, nah, you're subtracting it. Please, I'll also check, but answer is absolutely fine. Please see. If you have any doubt, do let me know, else I'll move on. 54 centimeter is absolutely correct, bhai. No doubt about it. Quickly let me know in the chat box. Done? Done, doston. Any problem from here? Can I move on? Clear? Chalo. Let's solve this question also. When a metallic surface is illuminated with a radiation of wavelength lambda, okay, I think we can do this in 60 seconds. If the same surface is illuminated with radiation of wavelength 2 lambda, the stopping potential is V by 4. Fine. You have to find out the threshold wavelength. First, they are saying when the radiation has wavelength lambda, that means Hc by lambda is equals to Hc by lambda naught, because they want us to find out threshold wavelength, plus stopping potential is Ev. And then they are saying when the radiation is changed to wavelength of 2 lambda, stopping potential will be V by 4, but this will not change. Threshold wavelength will not change, and this will become Ev by 4. Done? Now, dosto, I really don't want this Ev, right? So what I can do is I can multiply 4 in this equation, and then I'll rewrite everything again. I'll rewrite this equation, that is, so first let me write down this equation only. So I'll get 4 times of Hc by 2 lambda is equals to 4 times of Hc by lambda naught plus Ev, and then I'm going to rewrite this equation over here, and we'll get Hc by lambda is equals to Hc by lambda naught and plus Ev. So this is 2, and now let's subtract this. Ev will get cancelled out. This will become 2 Hc by lambda minus Hc by lambda is equals to 3 Hc by lambda naught, and Hc will get cancelled out, and I believe this will become 1 upon lambda. 1 upon lambda, and that will be 3 upon lambda naught. So lambda naught will be equals to 3 lambda. D is the correct answer. Good, chalo, great. Bhai, but what is happening to the chat? I can't. Henry, Robin, everyone, quickly write down in the chat box. You guys are not able to attend the poll. Please see. D is correct, na? So why your answer is not getting reflected on poll? Chalo Mohan, this is for you then. This is for you. A long straight wire of radius A carries a steady current I. The current is uniformly distributed over its cross section. The ratio of magnetic field B and B dash at a radial distance of A by 2 and 2A respectively are. Chalo. This is for you. 60 seconds. Start. I've asked them to check, but even without pole lengths, this it works actually. Just a second, then let me call them. You attend the question till then. I think we won't be able to change the poll in mid session. That's what they are saying. I've asked them to check it again. Let's see. Chalo, till then, I think poll will be working if you're going to write down in the chat box. At least for some people it is working. In this question, dosto, they are saying that we have got a long straight wire of radius A. Okay, so I can actually draw the cross section diagram. Okay, I can draw the cross section diagram and it will look something like this. Let's say this radius is A. Steady current radius is A. Right, and then you have got 2 points one at a radial distance of A by 2, one at a radial distance of A by 2 somewhere over here, and another at a distance of 2A, let's say somewhere over here. Just a second, we are trying to fix your pole. Okay friends, well that is not, I mean, I don't know, some another poll has started, but fine. See, now let's say this is point A and this is point B, right? You should know that magnetic field inside the conductor is directly proportional to, or obviously when we are going to talk about solid cylinder, right? You can solve it using Ampere's law, and the next thing is that magnetic field outside the cylinder is 1 upon r. So now they are talking about the ratio of magnetic field B and B dash. So ratio of magnetic field B and B dash will be, let's say this is R1, this is R2. So R1 1 upon R2, like this. Is it clear, my dear friends? Is it absolutely clear? So R1 is, I believe, A by 2, and R2 is, I believe, 2A. So this will become A square, but this will get cancelled out, and we are not going to consider A square, so we are going to select our answer as third. Very good. Some of you have doubt. See, this is working now, bachche. Because this is working. I have not changed anything. All you need to do is, under given time, write down your answer in the chat box. Okay, this is working. Acha, hopefully you don't have any doubt with this A square. Okay, we don't have to look for A square. We have to look for what? Look for the magnitude. So that is going to be 1. Clear? Moving on. Chalo, write down in the comment section if you have any doubt. This is from JEE Mains 2020. You have to find out the magnetic field if electric field is given. Okay? Magnetic field if electric field is given. 60 seconds is, I think, is fine time. Electric field is E naught j cap cos omega t minus k cap. Everyone should know that by looking at this, we can say that electromagnetic wave will be along plus I cap, because this is traveling in positive x axis. So electromagnetic wave is along plus I cap. Okay, clear? Then electric field is along j cap, and we know E cap dot cross B cap is C cap. So j cap cross, we want to know, should be equals to I cap. Is it clear, my dear friends? Done. So j cap cross k cap. So when you are going to find out magnetic field, this is absolutely wrong, and this is absolutely wrong. Either it's going to be this or this. Now the next point is, my dear friends, E naught divided by B naught is equals to C, and C is equals to 1 upon under root epsilon naught times mu naught. Hence we can write down, instead of B naught, you can write it down as E naught divided by C, or E naught 1 upon C can be written as under root of epsilon naught times mu naught. So finally, if you want to write down the equation, first of all it will be in k cap, but magnitude will be E naught multiplied by this. Okay, sometimes actually students do this mistake. They think, sir, obviously it will be E naught divided by C, and that's how they actually choose this option. So don't do any mistake. Option B is going to be the correct one. Clear? Done, my dear friends. Now let's check if pole is working or not. See, it's working, है ना? But what happens is that I think pi length is slightly quicker and better, but the problem is that at the start of the class, by mistake, the studio in charge has actually applied the wrong pole, है ना? So now if we'll change the pole, it will waste a lot of time. So no problem, we'll survive with this, and in the next class we'll have pi lengths for sure. ठीक है? चलो. Right now what you guys can do is you can quickly write down the answer in the YouTube chat. There might be a time delay, that's why your answer is not getting reflected over here. Moving on to the next one, my dear friends. Chalo, this is also a conceptual question. 60 seconds, let's start. Read it from JEE Mains. Formation of real image using a biconvex lens is shown below if the whole setup is immersed in the water. If the whole setup is immersed in the water without disrupting the object and the screen positions, what will one observe on the screen? What will one observe on the screen? What will one observe on the screen? No change. No change. Are you sure? Think about it. See, if you are going to actually immerse this in water, na, focal length will change. To all those students who are saying no change, this is 1 upon f is actually a mu L divided by mu S minus 1 times 1 upon R1 minus 1 upon R2. Okay? Even if it is, I mean, we don't care what it is, whether it is biconvex and equiconvex, but problem is with this. If you are going to put it inside a water, this mu S will become refractive index of water. Got it? So because of this, focal length will change, and if focal length will change, image will not be produced at the same point for same distance, because you are not changing distance. So if you are not changing distance and you are changing focal length, image will be produced but at somewhere else, at some another position. So at the same point it will not appear, so image will disappear. Got it? Clear? Right? Image disappears. Whenever a nice question comes, the percentage actually falls. So now 50% only of you have got it correct. Acha, might be poll is not working, so I won't take this very seriously. But if you have any doubt, do let me know. Quick. Come on. Any problem? Chalo, let's see if what this question says. For a thin convex lens, radius of curvature is this, focal length is this, refractive index of the material is. I think we can do it, hai na? Chalo, let's quickly solve this question. So they are saying, and then I'll find some good questions for you, don't worry. Focal length is given, we are going to again use the same formula, mu minus 1 upon r1 minus r2. So focal length is 20 centimeter, mu minus 1, and this is by the way convex, so 1 upon 15 minus plus 1 upon 30. So times 2, so this will become 1 upon 20 is equals to mu minus 1, and this will become 4 upon 30. Fine. Everything's clear. You can cancel out this 0 and you can transpose this. This will become 3 by 2, and you can write down 4 also over here, and then plus 1 is equals to mu. Chalo, find the answer bhai, whatever you are getting. So mu will be 3 plus 8 divided by 8. This will be 11 by 8. Come on. B? Are you sure? Pakka? Nahi. I'll check. First of all, check the calculation. I think calculation is absolutely fine. Calculation is absolutely fine. .4 is the correct answer. 1.4. Use. There is 1.4 also and 1.5 also. Okay. Sir, pollution is working. Poll is not working, pollution is working. Just a second. Let's check it again. Just a second. So this is 3 times 2 and I have multiplied 4. And now 1 upon r1, convex length 20 centimeter, curvature is 15 centimeter, right? 15 and 30 na, so 2 array yaar. My bad. 2. ठीक है, गलती. This has to be 2, so this will become 3 by 30. That is 1 by 10. Fine. Mu is equals to 1.5. Defeat accepted. B option is absolutely correct. Correct. B option is absolutely correct. Okay. Fine. Moving on to the next question. This is a nice problem. To all of those students who want to level up, this is for you. Mohan, this is your question. They are saying when an object is kept at a distance of 30 centimeter from a concave mirror, right? The image is formed at a distance of 10 centimeter. If the object is moved with a speed of 9 centimeter per second, with which image will move? The speed with which image will move. Chalo, 90 seconds, let's start. Come on. For this one, you have got a concave mirror over here. You have got a concave mirror and its focal length is given by, its focal length is not given, kya? When an object is kept at a distance of 30 centimeter from the concave mirror, its image is obtained at 10 centimeter. Okay, so let's suppose its focal length is f. Okay, an object is at this distance. Now please understand. Let's suppose we have got 1 upon f is equals to 1 upon v plus 1 upon u, right? And we want to differentiate it. Okay, now we want to differentiate it with respect to t. So differentiating focal length with respect to t will be 0. Now differentiate V with respect to mirror. That's what we need to do. So what we are going to do is differentiating 1 upon V with respect to T. So for this we'll have to multiply dV, right? We'll have to multiply dV and dV. That only then we can actually do this. ठीक है ना? Hopefully this concept is absolutely clear to you. So differentiation of V with respect to T is going to be simply minus 1 upon V square dV, and this will be minus 1 upon U square du. ठीक है? So that means we are going to write it down as minus V square dV is equals to 1 upon U square du, dV by dt and du by dt, dV by dt and du by dt. And from now on you can simply remember it. And see why I am explaining you this derivation, because in your RE-NEET exam they can also tell you that this is velocity of image with respect to, this is actually velocity of image with respect to mirror, and this is velocity of object with respect to mirror. But right now, because they have not mentioned anything about mirror itself, that means we are going to assume obviously this is at rest, so we don't have any problem. Clear? We don't have any problem, right? So this will become velocity of image minus velocity of mirror is equals to minus V square by U square, velocity of object minus velocity of mirror. Everything is in vectors, by the way. Okay? But right now, because mirror is not moving, this will become 0. And from now on, you can directly use this formula. Remember this. Alright, clear? Dosto? Sorted? Quickly write down in the chat box if this derivation is absolutely clear. You only have to differentiate it. Focal length will not change even if things are moving, and all of these distances are measured from mirror. That's why we are writing it with respect to mirror. This is written as this dV by dt is velocity of image with respect to mirror. ठीक है? अभी now please understand, they are saying when an object is kept at a distance of 30 centimeter, that means object distance is minus 30 centimeter. The image is formed at a distance of 10 centimeter. ठीक है? So image is formed at a distance of 10 centimeter. Clear? And then they are saying that if the object is moved with a speed of 9 centimeter per second. So just substitute it here. They want us to find out velocity of image. So write down negative sign. V is 10, this is 30, square it, and velocity of object is 9. Chalo, this is going to be 1 centimeter per second. Clear? B. Quickly let me know in the chat box, dosto. All sorted, all done. This was a moderate level problem. Very good. Very good. See, the poll is working. So from now on, remember it, and also remember that this is with respect to mirror and with respect to mirror. Okay. Moving on to the next question. Let me give you some more questions. Let's solve this one. Two cells of EMF E1 and E2 with internal resistance R1 and R2 respectively are connected in a closed loop with opposite polarity and no external resistance. What is the potential difference across the terminals of the cell E2? 60 seconds, let's start. See what they are saying. They are talking about that, let's suppose we have got an EMF E1 with some internal resistance, and E2, they are connected in with opposite polarity. So that means something like this. And there are no external resistance. ठीक है? There are no external resistance. So no external resistance, and this is E1 6 volt, and internal resistance is of 1 ohm, and internal resistance of this is 3 ohm, and this is 2 volt. What is the potential difference across the terminals of the cells E2? Dosto, first of all, let's find out E-net. E-net will be 6 minus 2, that is 4 volt. R equivalent will be 1 plus 3, that is 4 ohm. That means current I will be written as E-net divided by R equivalent. So this will become 4 divided by 4, that means 1 ampere. Now please understand, when somebody asks you terminal potential difference across this, please understand current is moving in this direction. So for this battery, for this cell, we are going to say that this is actually under charging. This is not discharging, this is charging. And whenever you are going to have charging case, please remember terminal potential difference is written as E plus IR. Alright, terminal potential difference is written as E plus IR, not E minus IR, because of charging. Because of charging. There are 3 cases are possible. If a cell is getting charged, terminal potential difference will be more than EMF. If it is discharging, terminal potential difference will be less than EMF. And if nothing is happening, it is ideal, then terminal potential difference will be equals to E. So this will become E will be written, V will be written as EMF E, and that is actually 2 volt plus current is 1 ampere, and internal resistance was 3. So that means this is going to become 5 volt. B is the correct answer. This is going to become 5 volt. Clear? B is the correct answer. Good. Some of you have thought, equal number of students has thought A, C and D. Okay. Chalo, let's solve another problem. Let's see this. An effective power of combination of 5. Acha. If somebody says effective power of combination of 5 identical convex lenses, that means P net is actually equals to 5 times of P. Is equals to 5 times of P, which are kept in contact along the principal axis is 25D. So this is equals to 25D, right? So power of 1 will be equals to 5, and that means 1 upon focal length will be equals to 1 upon 5 and into 100 in centimeter. So this will be 20. 20 is the correct answer. Bache, clear? Easy question from, this is again from optics. Let's solve this question. Be quick. 60 seconds is sufficient for this. Refractive index is given as √3. They are talking about minimum deviation. The minimum deviation is equals to the angle of prism. Okay. So minimum deviation, which is generally written as 2I minus A, right? And del I and these are also same. So that means I and del are also same. What is the angle of the prism? Chalo, find it out. Quick. Find it out. Be quick. Minimum angle of deviation is 2I minus A, na? And, right? And refractive index is written as sine of A plus del minimum divided by 2 whole divided by sine of A by 2. But, or they have told us that this is √3. They have told that this is √3. So we are going to write sine of A and del minimum are same. That's what they are saying. Minimum deviation is equals to the angle of prism. Minimum deviation is equals to the angle of prism. So this I can actually write it down as 2A divided by 2, that is A, and this will be written as sine of A by 2, and this is equals to √3. Chalo. Acha, you might not get the correct answer, but nahi, you will get the correct answer. I don't think there will be any problem. So see, after this, if you have any doubt, sine A can be written as sine 2 times of A by 2. This was actually, if you don't want to cancel it, no worries. You can write it as sine of 2 times of A by 2, which means that we can again write it down as 2 sine A by 2 cos A by 2 and divided by sin A by 2. So this will get cancelled out, one of them will get cancelled out, and this will come out as root 3. So cos A by 2 will come out as root 3 by 2, which means that this angle is A by 2 is cos inverse of root 3 by 2, that is 30 degree. So A will come out as 60 degree दोस्तों. Is it clear? A will come out as 60 degree. Good, very good. Done? Quickly let me know in the chat box. D is the correct answer. Cholo bhai, is there any doubt? Some of you have also said C, but I believe D is correct. If you have any doubt, you can ask me, else I'll move on. Be quick. What about this one? They are saying in a YDSE, in a double slit experiment, monochromatic light fringes are obtained on a screen placed at some distance on the plane if the screen is moved by 5 into 10 to the power minus 2 meter towards the slit. Please understand what they are saying. The change in fringe width is this. Please understand. They are saying that if the screen is moved by this, right, towards the slit. Chalo, if you guys want, I'll start the poll also. 90 seconds. See, I'll draw the diagram for explaining it. Basically, what they are saying is, let's suppose you have got initially screen over here. And this is where the slits are. Okay? This is where the slits are. Let's say initially the distance is capital D and this is small d. Okay? And then they are saying if the screen is moved by this, so initially beta was lambda capital D by small d. Now the new beta dash will be lambda will not change, small d is not getting changed, this will become d dash. And because they are saying moved by towards, that means now the new distance is this and this will be d minus x. So this will be lambda times d minus 5 into 10 to the power minus 2 whole divided by small d. And then they are saying change in the fringe width. Change in the fringe width is this. Okay, fine. Chalo, everything is given here. Everything is given, right? No problem. So change in the fringe width will be lambda d divided by d minus lambda of d minus 5 into 10 to the power minus 2 whole divided by d is actually equals to 3 into 10 to the power minus 3. This is the answer. I mean, this is the equation. Okay. If you are going to solve this, दोस्तों, I'll take out lambda upon d common and I'll get d minus d plus 5 into 10 to the power minus 2 is equals to 3 into 10 to the power minus 3. And remove this small d from here and multiply it over here, and they have also said small d is 3 into 10 to the power minus 3. Now, sorry, small d is 1 millimeter. So 1 millimeter, bache, please understand everything. This is in nanometer. Okay? So what we can actually do over here is this is in meter, right? This is in meter and this is in centimeter. So first let's write it in meter. So this will become 10 to the power minus 5. Right now this is in meter, over here it was in centimeter, multiplied by small d, that is 1 millimeter. So matlab 10 to the power minus 3 meter. Clear? Done. This d and d will get cancelled out. So lambda will become 3 into 10 to the power minus 8 divided by 5 into 10 to the power minus 2. Further, this will be written as 300 divided by 5 into 10 to the power minus 8. This will become 6t. So, or you can rewrite this thing as 600 nanometer. 600 nanometer is the correct answer. Nice problem. Okay? Nice question. Because fringe width is an important topic for you. And second, this is not an easy question, because they are talking about changing the width changing the separation between the screen and the slits. And some students might think, sir, how we are going to do, because we don't know capital D and we don't know lambda, but capital D will get cancelled out. Okay, so C is correct. Chalo, let me know in the chat box if you have any doubt. C is absolutely correct. Very good. Great. Any problem? Sorted? Let me know in the chat box. Chalo, let's solve this question. 2019. Okay, let's solve this. Under 90 seconds. Be quick. In a double slit experiment, when light of wavelength 400 nanometer was used, the angular width of the first minima formed on the screen 1 meter away was found to be 0 degree. दोस्तों, angular width, beta is lambda capital D divided by small d. Angular width is beta divided by capital D. So this is lambda divided by small d. And it found out to be 0.2 degree. Now they are saying that what will be the angular width of the first minima. Initially, first also they were talking first minima. If the entire experiment, if you are going to dip the entire experiment, it will become lambda divided by mu times d, and this will become theta. Okay, this will become theta. Hopefully everything is clear. So this is theta dash. So theta dash will be, dosto, lambda divided by d is 0.2 and divided by 4 times 3. So solve it here now. This will become 0.1 and this will become 2 and this will become 1.5. So 0.15 degree is the correct answer. Clear? B is the correct answer. Why? Just a second. Check. Lambda will be lambda by mu, na? Lambda will be lambda by mu. Lambda will be lambda by mu. Please see, lambda will be lambda by mu. Instead of, if you are going to dip it in water, wavelength will change. Wavelength will become lambda divided by mu, and this will become lambda, and mu is 4 by 3. Okay, this is 4 by 3. So nu theta dash is going to be lambda divided by d, and let's write it as lambda dash. So instead of lambda dash, you're going to write lambda divided by 3 lambda divided by 4 into d, and this will be 3 by 4 multiplied by 0.2. Clear? Done? Any doubt? Mohan, any doubt, bachche? Is it sorted? Please check. Please check. Clear? Chalo. One question from angular fringe width. Now let's move on. Alright, so most of the questions are done. Let's solve some more problems and then we'll conclude the session. 1 or 2 questions of assertion reasoning. The binding energy per nucleon is practically independent for atomic number from the mass number in the range 30 to 170. Nuclear force is short range. Chalo, tell me the answer. Be quick. Tell me the answer for this one. Tell me the answer for this one. Come on. Binding energy per nucleon is practically independent for atomic number for nuclei of mass number in the range 30 to 170. Reason is nuclear force is short range. So nuclear force is definitely short range. Okay? No doubt about it. Nuclear force is definitely short range. is happening? Just a second. Okay, I'll use another page. Nuclear force is definitely short range. Nuclear phase force role is that it has got proton, proton and neutron, neutron, right? Few properties about nuclear force. First of all, the force between proton, proton and proton, neutron and neutron, neutron remains same. Second is definitely it is a very, very short range force. If distance is going to increase, it will fall drastically. It will fall drastically. Okay? So definitely this statement is absolutely correct. That reason is absolutely correct. Now the point is that binding energy per nucleon is practically independent for number between range for mass number 30 to 170 is not absolutely correct, right? It is not absolutely correct. It will, because as we know that binding energy per nucleon for iron is maximum, and for Fe it is maximum. So reason is absolutely correct, but assertion is not correct. Clear? So doston, with this, let me give you one or two more questions, then we'll end the session. In YDSE, slits are separated by a gap of 0.5 mm. So this is 0.5 mm. And then the screen is placed at a distance of 0.5 meter. The distance between the first and the third bright fringe formed when the slits illuminated. Chalo, let's solve this. They are saying distance between the first and the third bright fringe. First bright fringe basically means 1 lambda capital D by small d. Third bright fringe basically means 3 lambda capital D by small d. So distance between them will be lambda capital D by small d times 3 minus 1, that is 2, and this will be equals to, this is what we need to find out, है ना? So let's put all the values. Lambda is 5890 angstrom and answer is in, so minus 10 into capital D is 1 upon 2 and this is 0.5, acha niche 0.5 mm. So 0.5 into 10 to the power minus 3 and multiplied by 2. So 2 will get cancelled out. You will have to solve it. This will become one more point. So we'll write it as 10 to the power 4. So this will be something 10 to the power minus 6. 10 to the power minus 6 is confirmed and this will come about. So I think option B will be correct. What do you say? I'll check the answer using calculator. Chalo. So this is 5890 divided by 5. Yeah, 1178. This is the correct answer, dosto. Correct? Quickly let me know in the chat box. This was not that difficult. Be quick. What about this one? In a YDSE, in a Young's double slit experiment, on the at a certain point on the screen, the path difference. Acha, they have told you the path difference over here. Path difference is 1/8 of the wavelength. 1/8 of the wavelength. So delta x is 1/8 of the wavelength. That means lambda by 8. And then they are saying the ratio of intensity at that point to that at the central bright fringe. So bhai at central bright fringe though intensity is maximum and we take it as 4I0. We take it as 4I0, right? So intensity at this point, for this point, let's find out first phase difference. So phase difference will be again 2 pi by lambda multiplied by lambda by 8. Lambda and lambda gets cancels out. This will become pi by 4. So pi by 4. So net intensity will be 4I0 cos square pi by 4. Acha, for this one na, because they are only talking about pi by 4. So I'll recommend you one thing, use this formula. Okay? Because you won't be able to find that answer na. So use this formula. I net will be I1 I0 plus I0 plus 2 I0 cos phi. cos pi by 4. Use this formula. This will be way better because else pi by 4 is 45 degree. It will become 45 degree by 2. Quickly write down in the chat box. Is this clear? Is this concept is absolutely clear? Answer will be in decimal, so you will have to solve and check. Chalo, quickly write down in the chat box if this is all sorted. And by the way, over here I have used the formula. I have directly used that I net can be written as 4 I naught cos square phi by 2, right? So maximum intensity will be definitely 4 I naught. But because when we are finding out delta phi for the next time, this delta phi is coming out to be 2 pi by lambda multiplied by lambda by 8. So lambda and lambda getting cancelled out. This is becoming pi by 4. So pi by 4 is 45 degree. Now if you are going to again use this formula, it will become 45 degree divided by 2. Got it na? So we don't know that. So let's use our normal formula. So this normal formula is I naught I1 plus I2 plus 2 under root I1 I2. This formula is I1 plus I2 plus 2 under root I1 I2 into cos phi. Okay. So use this formula. It will be in some decimal, but you will get your answers. Okay. Clear, my dear friends? Quickly let me know in the chat box. This is all sorted. What about this one? The ratio of intensities at 2 points on the screen, same type of problem. Phase difference between the two waves of amplitude are pi by 3 and pi by 2. Okay. So they are saying ratio of intensities at a point P and Q on the screen, where this is the where phase differences are this. So again, yeah, simply use this formula. I net will be equals to 4 I naught cos square pi by 6, and let's say this is I1, and I net 2 will be 4 I naught cos square pi by 4, and then take the ratio of these two. Clear, dosto? This is all sorted. Quickly let me know in the chat box. Be quick. Done? What will happen to this? Chalo, one poll question for you. 60 seconds. Let's start. If the monochromatic source is in YDSE is replaced by white light, then what will happen? If monochromatic source in YDSE experiment, YDSE is replaced by white light, then what will happen? Interference pattern will disappear. There will be central dark fringe surrounded by few colored fringes. There will be certain central bright white fringe surrounded by few colored bright fringes. All bright fringes will be of equal width. What will happen? Absolutely. There will be central bright fringe surrounded by few colored bright fringes. And if I'll ask you which bright fringe will be nearest to the central bright fringe, then what will you say? Let's suppose this is the central bright fringe. Okay? Because at central bright fringe, what happens is that all the colors at this point, delta x is 0 for all colors. Now I am saying ki which one is going to be the first maxima? Which color will be appear here for first maxima? Red or violet? Which color will appear first as bright fringe? I mean, obviously each and every color will have its own first maxima, but I am saying which will be appeared first. Which will be appeared first. See, now this is slightly confusing. The answer should be given if, let's suppose, they are saying which color will be there, right? So if they are saying which color will be there, then you are going to talk about beta, lambda capital D divided by small d. Now beta depends upon capital lambda. Now lambda is maximum for red. and minimum for violet, right? Minimum for violet. Now the point is that if you are going to say ki which one will be the nearest, which one will be the nearest, then the answer should be violet. Which one will be the nearest, then answer should be violet. But sometimes in some books or in some materials they can say कि red will appear first just because our eyes are more sensitive to it, but that's not the correct way. We are going to obviously we are going to obviously tell answer by using the fringe width formula, and fringe width directly depends on lambda. So more lambda, that means more fringe width. So for first maxima, if let's suppose violet is happening over here, let's say this is beta for violet, then beta for red will be over here. That's what I'm trying to say. Okay. So anyway, answer correct is C for this. Very good, bhai. This is a very common and famous question, so don't do any mistake. Okay. Chalo. Moving on to some more few last problems, my dear friends. This is very easy. So do this question in homework. You will get this PDF on PW WhatsApp channel. So there are going to be various questions for your homework. Let's do one question from here also. Starting the timer, 60 seconds. Let's start. In a thermodynamics process, pressure of a fixed mass of a gas is changed in such a manner that gas releases 20 joule of heat. Okay. See, if it is releasing 20 joule of heat, that means we are going to take it as negative. And 8 joule of work is done on the gas. 8 joule of work is done on the gas. Clear? Quick. And then they are saying that if the initial internal energy of the gas was 30 joule, the final internal energy will be. Come on. Use delta Q equals to delta W plus delta U. So they are saying that it releases 20 joule, that means this is minus 20. And then work is done, that means plus 8. And then plus delta U. So delta U will be minus 28. Clear, दोस्तों? Is it fine? Final internal energy. Initial was 30. Come on, quickly write down in the chat box. It is releasing, we are not giving heat, it is getting released, and work is done on the gas. So if work is done on the gas, then we are going to write this. Clear? So delta U will be final minus initial, minus was 30, and this will be minus 28. So U final will be, is there any trouble kya? Hopefully no doubt in question. Let me check the question first. Question is all sorted. Question is all sorted, dosto. Gas is getting released, so that is absolutely fine. Initial energy was 30. I don't think so there's any trouble in our concept. What do you think? Options are wrong. No, I have checked options. Options are also correct. There is no misprinting. I have checked, there is no misprinting, dosto. Maybe. Options are correct, bachche. Options are not wrong. Options are correct, and our concept is also correct. Concept is also correct. 20 joule of heat is released, right? So this is going to be definitely negative, minus 20, and this is going to be also plus 8. This is also correct. Work is done on the gas. This is going to be minus, and this is going to be delta U. So delta U will be minus 12, and UF minus UI is equals to minus 12, and UF will be equals to minus 12 plus 30, right? So it's going to be 20, right? And 18 joule is going to be the correct answer. 18 joule is going to be the correct answer, dosto. Work done on the gas is 8. Something is wrong. Yeah, I think with this option A will be the correct answer. You are saying third? नहीं यार, third नहीं. Third नहीं. No, not third. A is correct. A is correct. अरे नहीं, ऐसा कुछ नहीं है. Please understand this thing. This law, first law is same, convention is only different, बच्चे. Delta Q heat given is used in two ways, one to work and one for this. ठीक है. If let's suppose gas expands, then positive, and gas compresses, then negative. ठीक है. Gas compresses, then negative, and we need to find out delta U, let's suppose, and they are saying it is getting released. ठीक है, it is getting released. So if it is getting released, we are going to take it as negative. Now the thing is, work is done on the gas, na? Work is done on the gas. That means it is compressing it. Say correct answer is 18. Don't worry, correct answer is 18. Next is, my dear friends, see this problem also. A lead bullet of 10 gram traveling at 300 meter per second against a block of wood and comes to rest, assuming 50% of heat is absorbed. Assuming 50% of heat is absorbed by the bullet, the increase in its temperature is. ठीक है. So first of all, let's find out the initial kinetic energy. Initial kinetic energy will be half m 10 divided by 1000 into v square. So v square is 300 ka square, right? And then 50% of this, assuming 50% of heat is absorbed, it comes to rest. So if it comes to rest, it will become 0. So 50% of this energy is getting converted into heat. ठीक है, 50% of, so increase in temperature. So increase in temperature will be this heat delta Q will be equals to ms into delta T. So this is delta Q. This is delta Q. Mass is given. Specific heat capacity is given. You can find out delta T from here. Delta Q divided by m into S. ठीक है, clear, right? Done. You can find it from here. Delta T will be equals to delta Q divided by m into S. All right. Now remaining questions दोस्तों are going to be for you. Solve them. Acha, this is a nice question. Solve this. This is a very nice problem. We have solved many questions from intensity and YDSE. please solve it. What will be the intensity in front of one of the slits of the screen placed at the distance d? Okay. So in this, what they are trying to say is that if, let's suppose, you have got d1 and d2, something like this, right? So they are talking about at this point, at in front of one of the slit, at this point. So this distance is small d, sorry, this distance is capital D, this distance is small d. So you can find out this distance, and then after finding out the path difference, phase difference, and then use the formula. Okay. So hopefully this is all clear. Aja, this question was very nice. Huh? Use it using this method. So after this PDF will contain some more questions for your practice. Solve it. What about this question? This is also I have given you in homework. Okay. So this was simply about finding out the direction of propagation. And what about this one? This is choose the correct option relating wavelength. So by these are all very simple. Always remember that use it using the extreme, like for example, as these are most energetic, right? I mean, gamma is more energetic, but amongst these, X-ray is going to be most energetic. This is going to be correct, then microwaves, then visible, and then X-rays. Okay, so this is very simple. Then what about this one? When an object is placed 40 centimeter from a spherical mirror, an image of magnification 1/2 is produced. To obtain an image of magnification 1/3, this is also a nice problem, but I think you guys can do this question. We have solved multiple optics question in today's class, so this will be done. Clear? Any more doubt from that thermodynamics question? Clear na? Be quick. Chalo then. All right. So you're going to find this PDF on WhatsApp channel. Clear? If you have any other doubt, do let me know in the comment section. I'll include that in my next class. Okay? Probably day after tomorrow we'll have physics class again. So I'll include that in that class. If you have any question, any doubt, done? Clear? Chalo. Bye bye everyone. Bye bye. Bye. Bye 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 bye. See you. See you in our next class on Monday. Okay? Bye bye. Thank you everyone. Bye bye. Bye. See you. Bye bye.